In the previous video we had talked about the OOP features of Java. So in this video we'll get started by exploring the OOP features as well as getting started with the basics of programming languages that are common across all the different languages. So we'll study things like decision making, looping and stuff. Okay, so let's get started. So we'll write our first class based program, or you can say a purely object based program here. So just remember that all the programs in Java are completely object oriented. Okay, that is, they are encapsulated inside a class itself, so you have no choice but to use a class. Okay, so just remember that thing. And we can also nest classes inside this thing. Okay, so what I will do is I will demonstrate the same for you. So here what I will do is I will first create a class that is encapsulator class. Okay, just name this thing as encapsulator. Okay, so we'll name this class as encapsulator, and what we'll do is I'll create some private variables here. Okay, private int txto, I can call it anything. Okay, and here what I do is I'll write a name here, public static void name, that is the function for calling the main method, string args. And once this is done, so what I will do here is I will try to access this variable, or you can say set the value of this variable. So it's an integer variable, so I can set an integer value for this thing. So let's see if this works or not. Okay, so here if I get to Java tools, okay, so I found the folder. So here encapsulator class, encapsulator dot java. Okay, see here I have written it as a private variable. So if I go and let's compile these things, let's see what kind of error we are getting, or whether we are able to access this variable or not. See here, it will show you an error that a non-static variable cannot be referenced from a static context. So here if I write static keyword, okay, so this is important whenever you are writing Java programs, to understand what is the difference between static and non-static. Okay, so static methods or variables are the ones that are instantiated or exist without the creation of a class. Okay, so here I have not created a class. Even then, if I want to access it, then I can access it using this thing. But what if I write it this way? Okay, private class embedded. Okay, and here I want to access that thing. Okay, I'll write a method called modify txto. So this is the method that I'm writing here. So let's see if I'm having the access for this variable. So here it is allowing to modify. So what I will do is txto. Okay, let's see if I am allowed to access it this way. See here, it will tell me that this method is a part of the class embedded, so this is not allowed unless I instantiate this class. So to instantiate this class, what I will do here is embedded e is equals to new embedded. So here what I am doing is I am creating the new class embedded. So now to access this method, what I am doing is I am writing this e dot modify txto, and after that I will display the value of txto again. Sorry, system dot out dot println. Value of txto equals to let's see here. So here it is showing me that this class also has to be static. So this is another, you can say, problematic thing here, because it wants me to make this class static as well. So if I write static here, so let's see if it allows. See here, it is allowing this thing, but this will be a problem if you are writing a bigger program. Okay, so you cannot make anything and everything static. So here it will show you the value, that is 30. Okay, so why does this ask to make all the methods or stuff that we are accessing outside from this thing static? So the idea here is that static variables can be accessed without any class. So that is why it asks us to make it static. So here if I change or remove the static part here, then this will be again a problem. Okay, so another thing that you need to remember in static is that the static variable has only a single copy. Okay, static variable has only a single copy. Okay, at this point it might be confusing a bit, but remember that it has only a single copy. So here what is happening is it is not allowing me, because this will be a problematic here. Why I am telling you, if I instantiate this thing here, okay, let's see what happens when I instantiate this thing as encapsulator e is equals to new encapsulator. Okay, and what I'm doing here is e dot txto, and this should give an error, but let's see how it works. See here, cannot find symbol modify txto here for this thing, because here this class might not be identified here. See here, it is giving you cannot find symbol for this thing. So because we have used the same name here, sorry, yeah, let's do ex here and let's see how it works. Sorry, ex. Okay, so here it is showing cannot be referenced from static construct, because I have used it this way. So now if I write ex, sorry, ee, okay, e dot txto, and here I will still have that error. Okay, because cannot be referenced from a static context. So what I need to do here is, if I, let's see if we can do this thing, if we can turn this into a non-static thing, and let's see how it works. See here, this will give you another error that this cannot be accessed through a static context. So you can do it this way. Okay, so here also you create another instance of this thing here. So what will essentially happen is, here you will be forced to create an instance of encapsulator, and then you will have to assign the value to that new instance. Okay, here also if I am calling it e, okay, even then these are two different copies of txto. So let's see, this should work. Okay, finally. Okay, so now when we type encapsulator here, okay, so now see here, this is 20 here, and here we have created this embedded class which was present here, and then we are calling this out and setting it to 30. But does it allow this thing to work here? Value of txto is still 20 because these two are now in different scopes. Okay, so when the value was static, it was the same variable txto which was modified in both the places. Okay, so this is the major implication of using a static variable, that is, it has only a single copy and it exists primarily before creation of the class itself. Okay, so you need not associate it with a class creation, or you can say object creation for that matter. So other variables, if you want to access them, you need to create their objects. Okay, so another thing that is, it doesn't go out of scope. Okay, if you declare a variable, it will not go out of scope unless and until the program terminates. Okay, so that is another implication of using a static variable, that it will not go out of scope. So in Java programming, or you can say the Java programming language, it has something called as a garbage collector which does the memory management for this thing. So this will not remove these variables and clear space for these variables unless the program is terminating, that is, the instance of that program is not terminated. This variable or whatever functions or whatever class you have made static will exist throughout the life cycle of the program. So this will be a major problem if you are putting too many things or junk as static variables. Okay, so for the sake of removing the errors, if you are doing everything, turning everything into a static variable thing, then your JVM will be overloaded. Okay, at this point. So make sure that your workflow is proper and that you do not turn everything into a static variable just because your Java compiler is giving you some error or warning for that case. See how it fits into the workflow and then only turn those variables into static variables. Okay, so this was about encapsulation. In the upcoming video, we'll see a basic program related to encapsulation. We'll take these things a bit further. We'll go into details of implementation and design using OOP. Okay, so that is the main primary objective of this, you can say, video series, to make people understand Java better. Okay, I'm hopeful that this will help people understanding Java better. Okay, thank you.